So today we're going to switch over to geometric sequences. And then we'll do geometric series, and then we'll do applications of geometric sequences and series, and then we'll take a quiz, and then we'll go on to infinite geometric sequences and series, and then we'll take the test, and then it's spring break. Okay? So, depending on how this week shakes out, is going to depend on when that stuff is. Right now, loosey-goosey with everything. Okay? So just so you know. So, a geometric sequence is a sequence that has a constant ratio between consecutive terms. Last week, we were talking about a constant difference. So last week, we were adding. This week, we are multiplying. Okay? A constant ratio between consecutive terms means that we are multiplying to get the next term. Two, 4, 8, 16, 32, so on and so forth. That is a geometric sequence because every time we are multiplying by 2. If you're ever unsure, we can eliminate the fact that this is not arithmetic, because when I add 2 on this first one, I would add 2 to get this one, but then I'd have to add 4 to that next one. So arithmetic is automatically ruled out just with a quick finding the difference between a couple of terms. Okay? The times 2 part. If I don't see that I'm multiplying by an R value, it's called an R value for ratio. Okay? So instead of adding D to get the next term, now we're going to multiply by R to get the next term. Okay? If I don't know what R is, how can I find it? Exactly. I take any term and I divide it by the term right before it. So in this particular case, I would take, so my R value is equal to 4 divided by 2, or 8 divided by 4, or 16 divided by 8, or 32 divided by 16. Either way, all of those are 2. Any term divided by the term right before it gets me off. Okay? So, R can be positive. Yes? Okay. What about, can R be less than 1? Yeah? Okay. So 100 here divided by 200 is the same as 50 divided by 100 is the same as 25 divided by 50 is the same as 12.5 divided by 25. All of those reduce down to 1/2. Can R be negative? Yeah. R can be negative. So here, in this particular case, R is equal to negative 6 divided by 3, or it's equal to 12 divided by negative 6, or it's equal to negative 24 divided by 12, or it's equal to 48 divided by negative 24. All of those reduce down to negative 2. Okay. So R can be positive. It can be less than 1. It can be negative. What's the only thing that R really can't be? 0. 0. Because we just have the first term, and then every other term would be 0. So that's really the only one that R can't be. I mean, it can, but you rarely do see it. You might see R be negative 1, and then it would just, the sign would just change every time. Sometimes you might see R equal to 1, but those are the three that we kind of shy away from. Okay? What I'd like you to do now is I would like you to determine if those 4 sequences are geometric, and if they are geometric, find the common ratio. First one, geometric, not geometric. Not? Okay? If you didn't see, you would take 25 divided by 15, and that would reduce down. I can divide both of those by 5. That reduces down to 5/3. 35 divided by 25 would also have to reduce down to 5/3, but it reduces down to 7/5. So that's a no. Okay? Is that one, we'll go a little extension problem here, is that one arithmetic? Yes, and what's my common difference then? 10. I'm adding 10 every time. So it might not be geometric, but it could be arithmetic. If it's not geometric and not arithmetic, it could be something else. You know, there might be some other pattern that we see. Okay? What about B? Yeah? Okay. So with B here, 4 divided by 1 is the same as 16 divided by 4 is the same as 64 divided by 16. All of those reduce down to 4. So yes, this is, and we have R equal to 4. Oops. C, negative 9 divided by 27 is the same as 3 divided by negative 9 is the same as negative 1 divided by 3, and actually they're all equal to negative 1/3. So yes, this one is geometric also, and we have an R value of negative 1/3. Okay. What about D? No? Okay. First one would be, so 4 divided by 2 is 2. 6 divided by 4 is 3/2. So that one's a no. Is that one arithmetic? Yeah? Yep, that is. Common difference then would be 2. Yep. Okay. When we get later on in this chapter, I'm going to ask, I'm just going to throw a sequence out there. I'm going to say, is it arithmetic? Is it geometric? If so, find this. And so you're going to have to determine, because they have different formulas for each one. So, speaking of formulas, here is the rule formula for geometric sequences. Any term, G sub n, is equal to the first term, g sub 1, times r, and here's where it gets a little confusing because r has a power to it now, n minus 1 power. Notice how we switched from a's to g's, because we went from arithmetic to geometric. Okay? So a and g, we switched off on. So we got any term is the first term times the common ratio to the n minus 1 power. So it says write the rule for the geometric sequence, then find g sub 7. Okay? Well, I need the first term, which, given the list, that's easy to find because it's the first number, the first one in the list. Okay? I need the common ratio. Do I know the common ratio? Yeah, because I can take any term and divide it by the term right before it. So my common ratio here is 2. Do we agree with that? Okay. So now I can go to my rule. G sub n is equal to my first term. What's my first term? 4. Now I use parentheses. Okay. So the 2 is going to go in the parentheses, and then n minus 1 is going to go in the exponent spot. Now, fight the urge between multiplying these two numbers. You got to fight that urge. It's not 8 to the n minus 1 power. You first have to do the exponent, and then take the r to that exponent, and then multiply it by the first term. Okay? Logic and your brain are going to get you farther than just trying to type it in on a calculator. Okay? Then it asks us to find the 7th term. So g sub 7 is going to be 4 times 2 to the 7 minus 1 power. 7 minus 1 is 6. So this is 4 times 2 to the 6th power. 2 to the 6th power is 64. And 4 times 64 is what? 256? Yes? Okay. I would like you to do letter B now, please. To find my R, I take any term and I divide it by the term right before it. So 1/2 divided by 2/3. Remember when we're dividing fractions, we reciprocate the second fraction and then we switch to multiplying. So that's really 1/2 times 3/2, which is 3/4. So my rule is g sub n equals 2/3 times 3/4 to the n minus 1 power. Okay? Now, I will tell you this. Fractions are your friends. Okay? I want fractional answers for everything this week. Okay? And next week. Fraction answers. I don't want decimals. I want fractional answers because they're exact. Okay? So then when I go to find the 7th term, that's going to be 2/3 times 3/4 to the 7 minus 1 power. 7 minus 1 is 6, so that's 2/3 times 3/4 to the 6th power. Exponent rules tell me that that is 3 to the 6th power over 4 to the 6th power. So this is 2/3 times 729 over 4096. 3 to the 6th power is 729. 4 to the 6th power is 4096. 3 goes into 729 243 times. 2 goes into 4096 2048 times. So the 7th term here is 243 over 2048. Not the uber small decimal that you would possibly get if you'd actually do that. Okay. Fractional form with all of your answers. Questions on that? Okay. Write a rule given one term. We had problems like this back in arithmetic. Okay. What do I need in order to write my rule? I need my first term, and I need the R value, right? Okay. So I need to write the rule. I need the first term, and I need the R value. Do I have one of those? Which one? R. But I don't have the first term. So that means I've got to find it. So I'm going to utilize my rule. G sub n is going to equal G sub 1 times R to the n minus 1 power. Okay. What is G sub n? Negative 16. If G sub n is negative 16, that means n is 6. And what's R? 2. Six minus 1? 5. 2 to the 5th power. How do I solve for the first term? Divide both sides by 32. Negative 16 divided by 32. Negative 1/2. So my rule here is G sub n is my first term, which was negative 1/2, times R, which was 2, to the n minus 1 power. Okay. That's a good stopping point for today.